Good morning. Today we're going to go over logarithmic functions in case you were absent or you just want to go over them again. All right, so a logarithmic function is the inverse of an exponential function. So if you look at an exponential function, it looks like this. 2 to the y is 32. Well, you would have to guess as to what 2 to the y is, what that y is going to be. So it helps us if we put it in logarithmic form. So we're going to talk about how we're going to put it in logarithmic form, and then you can eventually put this in your calculator. So let's go and look at some exponential functions and write them in logarithmic form. So I use variables to tell me what order to put these in. So the large number here is the base, and then we have an exponent. Our exponent is 3. And then what we get out is our answer. So if you can just remember using letters B, E, A, you'll be able to remember what order to put them in. So in logarithmic form, we write log base B, and then we're actually of the answer is equal to the exponent. So we're actually looking for the exponent. So in order to do this, now it does have the acronym BAE, so if helping you remember it has the acronym BAE, that might help you also. You could also just remember you're going to keep your base the same in the same spot, and you're going to switch the other two numbers around. Okay, so in this case, 4 to the third is equal to 64. We're going to write log base 4. And then our answer was 64, so we're going to put 64 here, and that's equal to our exponent, and our exponent here is 3. All right, let's try another one. So let's go over here. We've got, this is our base, this is our exponent, and this is our answer. So we're going to go ahead and write it out as a logarithm. So log base 3 stays the same. And then we just switch our answer and our exponent. So 1 over 27 is written in normal size, and then we've got, sorry about that, and then we've got our exponent that comes around, and that is over here. Okay, let's go backwards with that. Let's go say we want to find, it's in logarithmic form and we want to write it in exponential form. You normally will not do this. You will normally go from exponential to logarithmic. But let's try it the other way around. Remember, this is your base, this is your answer, and this is your exponent that we're looking for. So our base is 125. Our exponent should be 2 to the third power, and we should get out at 25. So if you're using your calculator, you can figure that out. 125 to the 2/3 power is 25, or you could think, what's the cube root of 125? It's 3. And then we're going to square it, and then we get 25. All right, try the next one. So you've got, this is your base, this is your answer, this is your exponent. So we're going to do base, and there's our exponent. 8 to the 1/3 is equal to 2. Well, we all know that. The cube root of 8 is 2. All right, let me show you what we're doing with these things. This is how we're going to put it in our calculator. So it's called, you want to know how to put this in your calculator. It's very cool. There's a change of base rule that we use, and we say all we do is the log of 64 over the log of 4. That's it. Okay? So this answer number goes here, and our base goes down here at the bottom. So once you calculate that, and log on your calculator should be right near the x squared button along the left side. So I'm going to hit pause for a minute so you can find it. Okay, so here's where we're going to put it in our calculator. We're going to press log, and then we're going to press 64, and then we divide it by the log of 4. Close your parentheses. Once you hit enter, you should get a 3 exactly. All right, so let's go back to our other page. So the answer is 3. And basically it says 4 to the third power is equal to 64, and that is true. All right, let's try another one. So let's say you've got the log base 2 of 1 over 16. You're going to write log of 1 over 16 is equal to, or over, the log of 2. So let's go into our calculator. I'm going to clear that out. Log of 1 divided by 16. And then we're going to do divided by again the log of 2. I do believe we're going to get a negative 4. There we go. We get a negative 4. All right, so that answer is negative 4. All right, let's go on and try this. So there's your rule. If you want to copy that down, that's change of base formula. We use this to solve equations. All right, so I'm not going to go through these too much. If you want to practice these on your own, you can. I think this comes out to be 3/2, and I think this comes out to be negative 3.9 something. Okay, you'll probably get 1.5 on this side with your calculator, but you should get 3/2 over here. All right, so let's go see why we use this in equations. All right, so there's two kinds of equations. First kind we're going to solve is like that. All right, so you're looking at this and you say, oh my gosh, I have no idea how to find x. Well, we could put it in exponential form. All right, and putting it in exponential form, remember this is your base, this is your answer, this is your exponent. So our base is 4. 4 to the x is equal to 65536. We have no idea what that is. There's no way we can guess that, so we're going to do the change of base formula. So all we do is figure this part out right here, right? Because then it's going to tell us what x is. How about that? All right, so now we've got log of 65536 divided by log of 4. Go ahead and put that in your calculator and see what you get. Okay, so I just put that in my calculator and I got 8, and that is the right answer. Okay, it basically says 4 to the 8th power is 65536. And that's all you do. All right, so let's try this one. Now, this one's a little harder. If we tried to do log of 49 over log of x, we don't have those tools yet to figure that out. So we're going to go put it in exponential form. So remember, this is your base, this is your answer, this is your exponent. So our base is x, our exponent is a 2, and our answer is a 49. So we're basically saying x squared is 49. Well, how would you solve that? Well, you could square root both sides, and you get x is 7. And that is really all you have to do with that. So when your x is down here somewhere else, it's probably better to put it in exponential form. All right, let's try another one. Now look at this. This equation, it says log base 4 of x equals log base 4 of 7, so therefore x is equal to 7. Why do you think this is true? Well, what do both of those sides have in common? They both are saying they're the log of 4. So basically, if you just cancel out your log of 4, all right, you're not really dividing or anything. You're just saying if the log of something is equal to the log of something else, then those two things are equal. So basically, when you have the same bases or the same logs, you drop the bases or the logs, okay? So let's look at this. Log base 4 of 2x plus 11, log base 4 of 5x minus 4, all right, basically says these two guys are equal to each other. So you're just going to set them equal, and you're going to solve your equation. All right, so let's remember how to solve equations with variables on both sides. All right, I'm just going through and doing this, right? So now you've got 15 is equal to 3x. If you divided both sides by 3, you're going to get x is equal to 5. All right, and basically what it's saying is if you put a 5 in here for x, you're going to get 2 times 5 plus 11. All right, 2 times 5 plus 11 is going to be 21. And then 5 times 5 minus 4 is also 21. If you worked all that out and put these in your calculator, you're going to get the same log. All right, let's try this one. Now, this is another symbol. This is called natural log. It's the same thing as a logarithm when you're working out equations. So you can just basically ignore them and just solve the equation as you see it. All right, so take a minute, get all your variables on the same side, and let's see what we get. Right? When you're all done, you should have this, right? Because you should have moved all of these little guys over to the other side. All right, at this point, you can either graph it and look to see where they cross, or you can factor it. Okay, if you graph it, you're going to look for these points right here. All right, so we've got, I'm going to factor. Factors of 14 that add up to 9 are going to be 7 and 2. And we end up with n equals -7 and n equals -2. One of these might not work. It might be extraneous, but for right now, we're good to go. All right, so your assignment is going to be, it looks like 3 different kinds of assignments that you're going to have. You had one from before, so don't read this right here. I want you to go to Google Classroom, and I want you to click on the assignments from March 10th. Click on the assignments, and you're going to see all these problems that I need for you to practice if you were not here. Okay, so you've got putting those in exponentials, putting that in logarithmic, a whole bunch of change of base problems that can be done in the calculator. They're very fast. And then solving the logarithmic equations. And all of these have the same log, so you're basically just solving equations. Okay, and then when you're done with that, I want you to go back to I want you to go to today's post, and I want you to look at the video called Properties of Logarithms. Okay, and then we will work on the assignment for that. Okay, all right, I will talk to you tomorrow.